So what kind of intrusion detection systems are there? First one is signature based. Signature based, that means you search for a known attack patterns, either matching the pattern on the packets or matching the patterns on the packet sequence, or heuristics, or protocol, or you decode the protocols that to see what people are doing. And I have a slide later on which gives examples of the signatures. Second one is rule based. Rule based is simply no student is supposed to access the grading database, or what we call webfac. If some student is found, then basically that's a violation of the policy, right? So that will be rule based. Anomaly based is some abnormal behavior. That was those two graphs. Is that nobody does 15 gigabyte a day, and suddenly you are transferring 15 gigabyte. We find you. That okay. I mean, this is all. Normally students do few kilobytes, and now you are doing 15 gigabyte. What's going on here? So that is abnormal behavior. Statistical or non-statistical detection. And now similarly, actually another extreme of this anomaly is statistical anomaly, is that we see what is the average and whether you are within the average range or beyond the average range, and how far from the average you are, right? So that would be statistical method. And the IDS by the name itself means detection. So generally the IDS will not do anything except it will tell somebody that we found something. Alert the console means send an email to the manager, or ring a bell or something. But if it also could also be automated so that it takes some action, in which case we call it Intrusion Prevention System, IPS. Intrusion prevention means it is not only detecting but also stopping it. Okay, it could block that access. So signatures. If you see a lot of ICMP requests at a single host, then somebody is trying to get to it. ICMP is like ping or trace or something like that, so those things generally don't happen. But if somebody is trying to do that, and it might be, I mean, it's against a single host. It could be that you are pinging everybody, so you are just trying to find out how many hosts there are. So those kinds of things you might detect. Connections of multiple ports using TCP SYN. So this is like port scanning. You're just opening ports on every port on a computer. A single host sweeping a range of nodes using ICMP. So this was the same thing as I said, opposite of the first one. A single host sweeping a range of nodes using TCP, and so this is multiple version of that one. And connection to multiple ports with RPC request between two nodes. RPC is remote procedure call. So connection to multiple ports with RPC request between two nodes. So some computer might call some other computer and find out what the ports are, and on that port ask for something to be executed. Anyway, so those are all examples only of signatures. And so IDS systems, and there are many of them. I will not go into any of the products here, but if you go to Wikipedia, you will find many. They will do this kind of detection. Anomaly-based IDS. So anomaly-based is basically we find out what is abnormal. So for example, if a host sends out a routing updates, that is not normal, and that could be an attack. Sudden change in the traffic characteristics, like we talked about, suddenly somebody is sending lots of traffic. Machine learning, and so the IDS could be learning machine learning. So I think basically the idea is that there are systems which use machine learning to find out how to detect attacks, and every time something is declared as false positive, that means it is good but be detected as false, it will learn and make up. So for example, right now for spam, Washu has a detector, and if you get something which is labeled as spam, there is a way to tell them, no, this is a ham. not in spam. Spam is good. And so then they will learn. All right? And I think similar things works with Google and other email systems where they detect a spam, and then you tell them, no, this is not a spam. This is a person I know, and everything else, and so on and so forth. So they will learn. So that is machine learning. And then data mining. And this is what you do these fuzzy rules to detect attacks. So all kinds of things have been done and are done by these security companies. All right, statistical anomaly detection. Statistical is mostly based upon the mean and the standard deviation and things like that. So you count the occurrences of specific events over time, and if the mean is too much, then you worry about it. If exceed reasonable value, assume intrusion. Used alone, it is not very good. Basically, it's very crude and ineffective. And people do extreme things once in a while. So it's not, but you have to combine this with something else. So you might have the other two previous things as in addition to statistical anomaly. Profile-based is that you characterize the past behavior of the users and detect significant deviation from this, and using multiple parameters. So it could be number of packets, size of packets, types of packets, application level ports and all that. So you just use many of these things and you measure an average user behavior and you just see whether this is extreme from a statistical sense. So basically one of the things that, one of the ways of preventing intrusion or detecting intrusion, not preventing, is audit. And every computer has an audit, actually, it turns out. Everything that is going on in your computer is being audited. So if you go to Windows, for example, and you go to Event Monitor, all right, they are monitoring when you installed what, when something happened, when security and all that, right? So every operating system has that, every router has that, every device that is designed has some kind of audit so that people can go back and see what happened when. So these are parts of all common multi-user operating systems. Detection specific audited records. And so, for example, in Windows they have a security log. Generally I found it empty anyway because, I don't know, I mean I probably detect it before they do or something like that, I don't know. But detection specific audit records created specifically to collect wanted information. So they might have some things which are very specific to certain things that they are looking for. And then you analyze these records to get the statistical properties so that you can decide when it is extreme. And you could analyze them over time with counters, gauge, interval timer, and resource use. So counter is number of how many times it happened. Gauge is at what rate it is happening. Gauge is like a speed meter. Counter is like miles meter. So counter is a cumulative and gauge is more of a per second kind of thing. Interval timer, and what is the interval between whatever is happening, and resource usage and how much resource is being used. So all of these things you monitor. Use various tests on these to determine if the current behavior is acceptable. You can use mean and standard deviation, multivariate analysis, Markov process models, time series models, operational models, all kinds of modeling people do. And the thing is, the audit is basically so that the key advantage is that no knowledge is required about anything. You have the data there. So it's like a log. Another name for audit is log. Rule-based intrusion detection system. So rule-based, I already said briefly, is that there are certain policies that might be in the organization, and then you analyze the audit records to identify and see, and you could generate the rules from them, or you could just use the rules from experts. So rule-based operational penetration arrangement use expert system technology. With expert system means machine learning in some sense here. With rule identifying known penetration, weakness patterns, and suspicious behavior. And so basically you just make the rules out of the what is happening. Compare audit records or state against rules. You relate machine so basically there are certain things that people are not supposed to do, and then you look at the audit records and you say, well, what is allowed in terms of count, gaze, and whatever we talked about before, and then make a rule. And they are usually machine and operating system specific. So there might be different rule for operating system like Windows opposed to Unix opposed to something else. Rules are generated by experts who interview and codify knowledge of the security admins. So there are people, security experts, who will come in and talk to the security administrators and then make up the rules for you. Quality depends upon how well this is done, and so basically your goodness of the rule-based implementation will depend upon how well those experts people find all the positive and negative stuff. Basically there are two kinds of IDS. One is something which is based upon each host. Each host has an intrusion detection system. It's like firewall in each of these. And network-based is that you keep something on the network in addition to the firewall. Actually what happens is there is an intrusion detection system which is in addition to the firewall. Firewall is more like an intrusion prevention system. It doesn't let some things happen, but whatever goes through the network, IDS will monitor it. And once it finds something, it might set an alarm, or it might ask the manager to change the firewall rules so that it doesn't result in any attack. So that is IDS, network-based, and this is host-based. And with the host-based, what happens is you have a central manager where these agents will report. So these agents, which are in every system, will send a report of, summary report of whatever is happening or whatever should not happen, all those alarms to central place where they can monitor now the whole company network. All right, this is in the book, is called distributed, they call it distributed host system or something like that, but I think this is much better name, is host based, HIDS, and NED is the network based, network IDS. The problem with the network IDS is that it's just too much traffic. It has to protect all the hosts, so it is not really scalable. Suppose you have 100 hosts today and tomorrow you have 1,000 hosts, network traffic will be just too much. So it's very difficult to do. Why this is scalable, host IDS, if you have today 100 hosts and you have 1,000 hosts tomorrow, then now you have 1,000 agents as well. So that is somewhat scalable with the traffic. So anyway, so the pros of the host IDS is that verification of success or failure of attack is possible because you have all the audit records. It is specific to a system. So it basically affects the performance of that system, but you can find out which system is being attacked. It is not limited by network bandwidth or encryption, and one per host is expensive. So basically, so the idea is, if you buy these agents, you have to get the licenses and you have to pay for it. So it may turn out to be that while it is scalable in terms of performance, but not scalable in terms of cost. This is scalable in terms of cost, but not scalable in terms of performance. And sometimes you may not even know where the attack is going to go to. So it protects all hosts, but it is very difficult to see all the traffic, so you end up doing sampling and you may miss something, right? Independent of OS hardware, and too much traffic to analyze is the negative part, but it is good part is that it doesn't depend upon Mac versus Windows. And this is good for DOS attacks because those things may not even reach, if you do it right, may not even reach the host. And this one is negative is that you can't really get single packet attacks and encrypted traffic because the NIST does not have any passwords, does not have the security keys, where the host systems have the security keys. So they can look at the unencrypted traffic. And so there are both kinds of things one can buy. So obviously there are companies who are in the security business, and included McAfee and Symantec and all that. They all sell IDSs of both kinds. You generally buy the IDSs which go on the computers because all you have is one computer, but companies buy those bigger boxes from them too. If you just put more money into it, and then the thing is, so you have to really size it to the number of users or the traffic. It's just that you need a gigabit machine as opposed to a megabit machine here. See, when we say something is scalable, actually everything can be scaled with the price. So I meant in that sense that without increasing the cost can you scale it, and so there is a limit. Here, there is, actually, if you go into detail, then obviously here the thing is you are paying the cost by having everybody use only 90% of the computer, because 10% is gone for intrusion detection. Over there, you have 100% of the computer, but 10% of the dollars are gone. So in that sense, it's not a very strict thing that we can discuss or argue too much about. But in that sense, is that this one is one device protecting hundreds of people. This is 100 people protecting themselves. And so this is more like a peer-to-peer. This is centralized. So peer-to-peer is supposed to be more scalable because there are more people. The next concept is honeypots. So honey is something that if you put out, all those bees will come, right? So the honeypot is a website or an email address or something which is strictly designed to watch who is coming. It has no useful information, but looks like very useful. So they might have a website just to attract, for example, FBI, CIA, and so on and so forth. They might have a website which has their name on it. However, it's just fake. And so, and so if everybody who comes there is somehow, is attracted to the information that is there, and they will be caught. All right. So companies are having honeypots. This thing. Today morning, I received an email from somebody saying that they want to use. So one of the projects in the 2009 offering of this course was honeypot. Somebody had written in honeypot. So 2 years later today, I got an email saying that I'm trying to use it, but I'm having any trouble. What do I do? I said, read the documentation. That's all you can do. I have no more information. But that's what happens is people, just related to your projects, people do come back much later and want to know what is going on. So anyways, honeypot is something that is a common thing, and each of us, you should have it too, have an email address which is honeypot. Is that it's a junk email address. Everybody asks for email address, you give it to them because you want to verify your email address. Okay, go ahead and verify, and after that you never read that email, right? Because it is just full of spam, right? That is a honeypot. But websites have, in particular, where they have a system, Decoy system, to lure attackers, and encourages the attacker to stay on so the system can respond. So basically, as soon as somebody comes on, there is somebody else on the other side who is watching what this guy is doing now. Now he's going to this computer. Now he's going to that computer. Completely being watched, 100%. So the attacker is thinking, oh, look, I got the password. Now I'm going to go there, but they don't know that they're being watched. So this is like a sting operation. Are filled with fabricated information, instrumented to collect detailed information on attacker activities, simple or multiple network systems. Password management. So the final thing is that the key thing that people are looking for is the password first. Once they get the password, then they look for something else, because then they become somebody and then they can do something. And therefore, this is what we have to, as a manager, we have to worry about, is how to save the passwords. And so login and the password. Now login is clear, password is the only thing that we can do. So password is used with hashing. In Unix, they use DES encryption. So basically, DES is used as a hash. Other Windows systems have, other hashes, like they could use MD5 or whatever, MD not 5, MD5, yeah. But they use it with a salt. What is a salt? So salt is basically a name for a nonce. Every password, when it is stored, they generate a random number. Actually, when it is created, let me not put it stored. When the password is created, they create a random number, and they use that along with the password to hash, and that hash is stored. And then the nonce is stored in clear along with the hash. So why do we do that? Well, the thing is that if we don't use a nonce, if we don't use the salt, then somebody can create a whole table for that hash, for all inputs, for all outputs. That is called a rainbow table. You could create the whole table, and then whenever you see the hash, you know the input. You don't have to do any calculation after that. So this could be pre-stored, right? With the salt, that doesn't apply, because now you have to create the whole table for one salt, for the second salt, for the third salt, and so you have just increased the problem. If somebody wanted to create all possible table for all possible salt, that would be a lot of work. Otherwise, they cannot compare the passwords. So, thing is, the reason for keeping the hash is later on when you want to use the system, you come and you give your password, they hash it again with the same salt, and they match it. It's like IV. Every IV is sent in clear, but that's a nonce, right? IV initial value, right? That's a nonce, but that is sent in clear, because then the decoder can only decode it if only they knew the IV. It just prevents people from, pre-computing. All right, so you know what is a salt now. Now, most recent systems use crypto hash rather than DES, and basically you should protect the password file on the system itself. So the whole file could have another password on it. So even though the passwords are stored, but to get to that file, you need some other things. Managing passwords is that how do you make sure that the passwords are all very good passwords? Is first you educate the users, and that means you give the guidelines for good passwords, require a mix of uppercase, lowercase, numbers, punctuations, and so on and so forth. So every system you go through has a different system, different rules, password policy. And then some companies which are not really very security knowledgeable, I would say, they have computer generated passwords. That means they will give you the password. They won't let you choose the password. And I complain to each of these when they do that. I say you are very insecure, because the only way I can remember this password is writing down on a piece of paper, and then everybody can read it. So the computer generated passwords are not a good idea, but if you do want to do it, and that is what is called sticky label syndrome, that you have to write it and put it on a sticker. Right? If you want to do it, then use this FIPS publication, which is a NIST publication 181, that produces passwords which are pronounceable, so at least you can remember them in the memory. Otherwise, who can remember GY4 semicolon 893? I mean, who remembers all this, right? So those computer passwords are no good for anything. But if you generate from this one, then at least people can remember with some image. And then there are two ways to check the passwords that are good. Is reactive checking, which means that you one day sit down and go through all the passwords offline using some kind of guessing tools, which is actually not recommended. What is recommended is proactive checking, which means that you check when you just select the password. So as soon as they select the password, you tell them this is good, bad, or poor, and then ask them to change right there. So nobody is allowed to select a bad password. And I have seen systems that will not let me select anything that has my name in it, my birthplace in it, or my, they have all my data, and then they want to make sure that none of that data shows up in the password. So that is proactive checking. All right, that brings us to the end of this chapter and the course in some sense. So the 5 key points for this chapter: that the intruders, even though the name intruder means like coming inside, could be internal, external, or organized. If it is external, it could be unorganized or organized. And so the organized ones are the most dangerous one. And internal ones are equally dangerous actually, but organized external ones are most dangerous one. Then the IDS can be signature based, anomaly, signature based means pattern based, anomaly based, abnormal behavior, statistical or statistical, and the goal is to minimize the false positives and false negatives. And both of them hurt. If you have lots of false positive, people will not believe the system. It's like this: if the fire alarm goes on every day here, and it happened once in our class, right? If it happened once, that's fine, but if it happens 10 times, we will not walk out of the room. We will just stay inside the room. People don't trust it anymore. False negatives. There was another good example recently. There is some kind of test that men or women are supposed to go every year or go after the age of 50 or something like that. Now that test is so many false positive that medical community has said take it off the list. And so that is false positive, right? IDS can be host based or network based, and host based is more scalable, as I said. Honeypots can be used to detect intruders, and then the password management requires education and proactive checking. So I would basically, reactive checking does not really help, and the computer generated passwords do not help.